Hi my friends, how are you? I hope everybody's fine. My name is Daniel Villarino. Welcome to my YouTube channel. In the two previous videos we saw how to do a couple of bolts without using the chuck and the jaws. Basically what I did is use this faceplate. Basically when you get a lathe, normally comes with one of these. But what happens if you don't have one of these? This video is to show you how to make one homemade, okay? And there are a couple of methods. I am going to show you today one of those, and in a future video I will show you the other method. What do you need? We are going to need some plywood. This one is 3/4 inch thick. It has about 8 inches here and 24 inches in length. And from a similar piece I already cut 3 of those and I glue them together like that. What else we are going to need? We are going to need a nut, and this nut will have exactly the same size as your headstock. Basically you need a nut that is going to be perfectly fitted for your headstock. In my case, this one has an internal diameter of 1 inch and 1/4, and it has 8 TPI, 8 teeth per inch. So that's the measure for my headstock. So you have to find exactly the type of nut that you need for your lathe, okay? And what you are going to do is put it here. I'm going to make a hole in this piece and carve it so that I can fit the nut in there. And once it's there, we are going to round this up and make the faceplate. Okay, so that's today's project. I hope you enjoy it. Let's get to work. First, I find the center, because there I want to place the drawing of the contour of the nut, and that way make the best use of the plywood. I trace a circle circumscribing the hexagon that I drew before. The idea is to chisel a hole to set the nut, but most of the waste will be removed with a Forstner bit that makes a hole close to the size of that hexagon. Probably the hole should have been made in the drill press, but mine is in the garage, and besides, this way we can see that the job can be done just with a portable drill. As I was drilling deeper, the bit was trying to make the plywood twist on me, so I decided to secure it to the lathe bed with a couple of clamps. Every so often, I vacuum off the shavings and measure how deep the perforation is. Now, I use a chisel to shape the hexagon hole. Although these scenes are sped up, it did not take me much more than 15 minutes, and I am no expert with a chisel. Although it is not critical, I want the bottom of the hole as flat as possible, so the nut will sit better there and there will be more surface for the gluing. Well, I know that I am far from being Michelangelo, but I think it will do just fine. Just in case, and so the gluing is more effective, I use some denatured alcohol to clean the nut surface from oil and grease. Perhaps acetone will work better, but if you use it, be careful with the fumes. I am going to cut a couple of strips of cloth that I will roll into a plug, which I will smear with wax and then use to fill the thread hole of the nut, to avoid getting epoxy there. Looking back, this might have been too much work, and perhaps a roll of nylon would have worked better than the cloth, but at the end, it achieved the objective. hit it with the mallet a couple of times, and then a few strategic taps to ensure that it has reached the bottom, and from there to let it dry. Although this is a 5-minute epoxy, I will leave it drying for a few hours to ensure that it has cured completely. On the other side, I found the center and I traced a circle, and I will take it to the meter saw to cut the corners and approach it as much as possible to a cylinder. Even as we are placing it on the headstock, we can see that it's running far from true. But we are going to take it to a cylindrical shape with a flat face anyway. Between the grain going in all directions and the hardness of the glue used to make the plywood, I had to resharpen the tool several times, but eventually I got it nice and true. With the help of a sanding board, I flattened the front face. To true up the back face is actually worth the effort, because that way the piece gets better balance. mark the face center. I am going to trace circles with a radius of 40, 60 and 80 millimeters. Although it is not critical to do it this way, I am going to use the lathe indexing system to place the spots for the perforations. First, I fix the plate, and then, with the help of the tool rest raised to the center position, I trace a line intersecting the three circles. Here, each hole in the axis is separated by 30 degrees, so it will take me 2 jumps to trace a line 60 degrees from the first. Two more jumps and I can trace the third line. The 18 intersections between the lines and the circles gives me the place to make the holes. I make a test perforation on a scrap piece of wood to make sure that the screw goes by tightly but without getting stuck. Again, the idea will be making these holes in the drill press, but as I said before, it is not critical. I make a bit of countersink to ensure that everything is flat. I use a straight edge to ensure that the surface is flat. Here, I am only cleaning up a bit the end of the nut. I measure the internal diameter of the axis to ensure that the bit that I will use will pass without damaging it. With a bit of 5/8 of an inch in diameter, I make a hole from face to face in the middle of the faceplate, and I use the lathe to make this perforation to ensure that it is precisely in the center.
I can't recall, so fill to me the parting glass, could spend and leisure time to sit a while. There is a fair lady in this town.
Because this faceplate is quite thick, I am going to countersink the holes in the back, so when I put the screws through them, they will fit a bit more in the piece to hold.
Cheeks and ruby lips alone she holds my heart enthralled. Then fill to me the parting glass. Good night and God be.
Okay, my friends, I finished making the faceplate, and as you can see on the back here, it has the nut that I put and glue there with epoxy, and then all the perforations at different distances to hold smaller or larger pieces. Which are the steps that require precision? Making the hole for this nut actually is not critical, and basically you have to try to put it as even as possible, but again, that's not critical, because once you put this on the headstock, the rest of the piece is what is going to be balanced, and you have to screw it up on all the surfaces. So once you have that screwed up, it will be even with the nut. So the position of the nut originally, do it as best as you can, but it's not critical that. And then of course this surface has to be very straight, and you saw that I use the sanding board to make sure of that. And this center hole is important that is made in the lathe, because later on what I'm going to do is use a dowel of 5/8 of an inch that is going to end in a point, and I will use that to center the piece on the piece that I want to work. The position of the holes really is not critical, and as you can see on the back here is less than perfect. So what is important is to have them distributed more or less evenly, so that when you place the screws, then the pressure that the piece is going to make on each of those screws is more or less uniform. Okay, but besides that, the position of this is not critical. I am using 2 inches long screws, and as you can see, when I put them there, it goes out about 5/8 of an inch. In my opinion, with 6 of these, penetrating that on the piece that you want to hold is enough. But if you want to have a little more bite, you can use 2 inches and a quarter, or you can make these perforations here, these countersinks, a little deeper. But I don't like that idea too much, because what I want is to have as much structural integrity on the piece as possible, and if you do these perforations too deep, you begin to lose that structural integrity. So the same method that you use to make a faceplate like this, you can make also a glue block. And in the case of the glue block, one of the considerations is that you have to know how deep the nut is, because from there to the outside is the useful capacity of that glue block. So since the nut goes to about here, in this particular case, I would have preferred to make it a little wider, so that every time that you use the glue block, then you can throw it up and then use it again, and so on and so on. And you can do those through ups until you get closer to the place where the nut is located. No further than that, because otherwise you can damage your tools. Compared to the original one that came with the lathe, they are pretty similar. The advantage of this one is that is quite inexpensive. The nut was about $3, and the cost of the plywood was about $3 as well. So in total, probably with $6 you can do one of these. Okay, my friends, let me interrupt just for a few seconds the epilogue of the video, because I would like to show you these pictures that were sent by some of my subscribers. From Mati in Vera, Argentina, this beautiful natural edge ball made in sable, and a mate made in black locust. Also from Josian in Las Piedras, Puerto Rico, this magnificent segmented goblet in almond tree, teak and plywood, and these very nice pens. And from Rafael in Granada, Spain, this elegant lot of olive wood pens, and also in this picture some more beautiful pens from left to right, cherry, purple heart, zebra wood, beech and American bog. So thank you all for sending the pictures. Big hug. Okay, I hope you enjoyed the video. If that's the case, please mark the like button down below, make comments, and if you haven't subscribed yet to my channel, please do so. And it will be until the next one. Cheers.